Algebra II 8.4b. Now we're going to do sums and products of quadratic solutions, and I have a theorem for you. We're up to 7 previous videos for this chapter. If you become lost or confused during the video, click on the description and watch the videos that can fill in what you're missing. All right? We can find and use sums and products of solutions of quadratic equations. So here's our theorem for the equation, and this is a quadratic equation in standard form, isn't it? Ax squared plus bx plus c equals 0. The sum of the solutions is negative b over a, and the product of the solutions is c over a. So we're going to take that second term, this b right here, and that's going to be the numerator, and the a will be the denominator, and we're going to set it as a negative. See, it's the inverse of the quotient of b and a. See that? And then the product is going to be of the solution is going to be this c over that a. It's going to be the quotient of c and a. See that? And if we write ax squared plus bx plus c equals 0 in this form, x squared plus b over ax plus c over a equals 0, then the sum of the solutions is the additive inverse of the coefficient of this x term right here, and the product of the solutions of the constant term. Now, look at this example. We've got 4x squared plus 3x plus 2. We can write the 3 over the 4 and the 2 over the 4. See? The sum would be 3/4. Be a negative 3/4, wouldn't it? And the product would be 2/4, which would simplify to a half. See that? So remember that this is going to be a negative b over a, and that's a positive c over a. Okay? So we can find the sum and product of the solutions without solving the quadratic equation. We've got 2x squared equals 6x plus 5. We have to set this into standard form of a quadratic equation like that. So what we can do is subtract 6x from each side and 5 from each side, or you could say we're adding a negative 6x and a negative 5. We're doing the opposite of the signs to create additive inverses, 0 pairs. So what we get is a big 0 here, and we get 2x squared minus 6x minus 5 equals 0. I'm going to let x sub 1 and x sub 2 be the solutions. Do you remember before, a couple weeks ago, we talked about how when you see the little 1 down here, that's a subscript, and that means the first one, and that's the second one. So we can say that these are the solutions. That's the first solution, that's the second solution. So x sub 1 is going to be the first solution. X sub 2 will be the second solution. When we add the solutions together and get a sum, it's going to be negative b over a. See? So it's going to be negative 6, negative of negative 6 over 2. See? And when we distribute that negative into there, it's going to be a positive, isn't it? And for the product, we're going to have our first solution and our second solution. And when we multiply them and get the product, it's going to be this negative 5 over the 2. See that? So if we simplify this and distribute this in, we're going to end up with a positive 6 over 2, aren't we? Which means it's going to equal a 3, isn't it? See? Now we've got x squared plus the square root of 2x minus 4 equals 0. We know there's an invisible 1 there, isn't there? So when we do this and we put this one on top of this one, we're going to have this negative square root of 2 over a 1, aren't we? And that just means negative square root of 2, doesn't it? For the product, we're going to have this negative 4 over that 1, so we're going to have a negative 4. See? So we can find the sum and product of the solutions without solving the quadratic equation. We can find a quadratic equation for which the sum of the solutions is a negative 4/5 and the products of the solution is 2/3. We set it in here as this is our first degree term. It's the negative b over a, so that's going to be the 4 over the 5, isn't it? And this is going to be a 2 over a 3. This negative gets distributed into there, so we have a positive 4/5 x. And we can multiply each term by 15, the least common denominator, to write the equation as an integer coefficients. Because we don't want it to be in fractions. We don't want it to be rational like this. We want it to be in integers. So we just multiply each term by 15, and we get 15x squared plus 60 over 5x plus 30 over 3. And when we simplify it, this becomes a 12, doesn't it? Because 5 times 12 is 60, and that becomes a 10. So we usually write it this way. So now we've got 15x squared plus 12x plus 10, and it's in the standard form of a quadratic equation with integer coefficients. All right? We're going to do this more in the next video. So we can find the sum and product without solving the equation, and the sum of the solutions is the additive inverse of that first degree coefficient, the b. So the sum is the additive inverse of the first degree coefficient, okay? All right, our next video, we're going to do what I said. We're going to find a quadratic equation from its solutions, and I'm going to put this into the Algebra II playlist. And if you're watching and you're really in Algebra I, that's fine. The Chapter 13 videos of 13.4a and b and 13.5 and 13.6 correlate with what we've been talking about a little bit. Not completely, but a lot. And those previous 7 videos for Chapter 8. So if you're confused, go back and watch those videos for Chapter 8 that we've done, and that will clear up your confusion, all right? All you have to do is go to this video's description and click on the links. Okay, I hope this was helpful. I hope you figured this out, and we're going to talk about this more in the next video, so I hope I'm going to see you there. Bye.